Okay, so today we're looking at integration of sine squared x and cos squared x. So the knowledge in integrating expressions of sine squared x or cos squared x is our learning intention. We'll be successful if we remember these formulas. Now on our formula sheet, we have these two. So cos squared nx equals a half 1 plus cos 2 nx, and sine squared x is a half of 1 minus cos 2nx. Now that is on page 2 of our formula sheet. Now the integrals integral ones are not there. That's okay. So these are ones that we should remember. Okay. So the integral of cos squared x equals a half x plus a quarter sine 2x, and sine squared x equals a half x minus a quarter sine 2x. So notice that this each are the same. From cos we get plus, and sine we get negative. And these are the same, so we get cos we get the plus, and then sine we get the negative. Okay. So here's the proof. So if I want to integrate cos squared x dx, using an identity that cos 2x equals cos squared x minus sine squared x, and then replacing sine squared x with the Pythagorean identity of 1 minus cos squared x, cos 2x is equal to 2 cos squared x minus 1. Making cos squared x the subject, I get a half cos 2x plus 1. Okay, and therefore if I want to integrate that, I'm going to replace it with this. Take out the factor of a half. So the integral of cos 2x is going to be a half sine 2x. The integral of 1 is going to be x. Multiplying by that half, I get a quarter sine 2x plus a half of x plus c, and fixing it into the formula into the same kind of method that we had. Okay. If I wanted to the proof of this identity, okay, we get still using the cos of 2x, right? So cos cos of 2x is cos squared nx minus sine squared nx. Using the Pythagorean identity, we get 2 cos squared nx minus 1. Making cos squared nx the subject, we get a half cos 2nx plus 1, giving us that identity. And that's the same. Similarly, you could do the same proofs with the sine 2nx. Okay. So we want to integrate cos squared x minus 1. So what that means is we want to integrate cos squared x minus 1. Okay, so we know that the integral of cos squared x is a half of x plus a quarter of sine 2x. Now the integral of negative 1 is just minus x plus the constant. Well, collecting like terms, a half minus 1 is negative a half. And just tidying it up so that we have a positive value at the front. gives us that. Okay. Let's find the integral of 2 sine squared x minus cos x dx. Well, that's going to be that minus integral of cos x dx. Okay. We're using our formula. The sine squared x is going to be a half x. Now sine is going to be minus a quarter sine 2x. The integral of cos is negative sine x plus c. Tidying this up, 2 times a half is just x. That's going to be a half of sine 2x. And this is going to be plus sine x plus c. Sorry. So that's going to be positive sine. Sine gives you positive, yep. So that's actually minus. Okay. Another example. Here we've got a definite integral from pi on 6 to pi on 3. Okay. I'm going to split it up. So cos squared x is a half x. It's cos, so it's plus a quarter sine 2x from pi on 3 to pi on 6 plus, that's just going to be x from pi on 6 to pi on 3. Okay. Multiply, so it's going to be x plus a half sine 2x okay. Subbing in our values. So what I'll actually write down is going to be 2 pi on 3 and that's going to be pi on 3 okay. Well, sine of 2 pi on 3 is sine of 60, which is root 3 on 2. Sine of pi on 3, which is another 60. Sorry. Yeah. and sine of 60 is pi is root 3 on 2. Okay, pi on 3 plus root 3 on 4 minus pi on 6 plus root 3 on 4 plus pi on 3 minus pi on 6. Well, that will cancel out with that. That becomes 2 pi on 3 maybe I'll do this, just clean it up. Pi on 3 minus pi on 6 plus pi on 3 minus pi on 6. Gives me pi on 3. Okay, and that's the answer to that question. Okay, so we're going to calculate cos of cos squared of 7x. So knowing that we're going to use this identity. Okay, so cos squared nx equals a half 1 plus cos 2nx. Okay, in this case, n equals 7. So cos of 7x is a half of cos 7 times 2 is 14x. So what we want to do is we want to integrate a half plus a half cos of 14x dx. Or we can take out that half anyway and have 1 plus cos 14x dx. The integral of cos 14x is 1/14 on sine 14x. And we don't have any boundaries. So if I want to clean that up, I get a half of x plus 1/28 sine 14x plus c. Alright, so using sine squared nx equals a half 1 minus cos 2nx. N in this situation is going to be a half, so a half of x equals a half 1 minus cos 2 lots of halves is 1 cos x. So it's going to be the integral of a half 1 minus cos x dx sine x positive cos positive sine Just to remember, when in doubt, so cos gives you a positive sign. There you go. So that should be dx. Should be plus c. Okay, good luck.